I'm gonna take a look at these Williamson amplifiers I made. So just doing some measurements. These amps are based off the Stancore Williamson schematics, just a basic Williamson 6SN7. In this case, we're driving 1625s, only because I have a lifetime supply of these new old stock, and they're a lot cheaper than A07. You just have to deal with the 12-volt filament and the different base. But anyway, I have a matching one over there. So I have this hooked up. I got a little breakout box here, and basically what it does is it's a pass-through cable that feeds these dummy loads, and then I have 3 takeoffs, a left, a right, a switched output, and a RCA with a 26 dB attenuator built in to feed RU. So I'm just feeding a Behringer. And one of the switched output is basically I put this across my meter, my bench meter to get the volts RMS AC. That's my signal generator. Actually, a new one I just had to buy because I blew up the other one by accident. I'll maybe make a video on that. But so signal gen's feeding the amp. Dummy loads hooked up across the speaker terminal. We have a left and right out if I'm doing a stereo amp. In this case, I'm just using the green output. So the switch, it just switches back and forth between which output you're monitoring. Anyway, what I wanted to do is just measure some of the performance. So I spent a long time dialing these things in stability-wise and tweaks, and hours and hours of playing around with capacitor values across the feedback values. I ended up with a Zobel network to really get these things dialed in across the I found it worked best across the 4 ohm tab. But so right now, this is also a very quick video of the RU too. It's what I use. So right now we are got a kilohertz feeding the amp, and our distortion is 0.17% at 20 watts. So RU will actually calculate your watts. As long as you calibrate your input voltage, you can set your resistance that it's going to calculate off of. So what I do is, since it's through the attenuator, I basically hooked up the attenuated output into my meter right here and measured it, got the millivolts RMS, then plugged it in and punched in the value that I got off the meter into RU as the calibrated value. And it's pretty close actually. So if you can see it's 12.74. That's obviously not the real voltage in, that's through the attenuator, but we got 12.75. So we're off by a little bit, 10-20 millivolts, which is irrelevant for the kind of work we're doing here. So nice thing about wattage, just easy number. Not that the math is hard, but in that percentage distortion, it's fairly accurate. I think 0.2% distortion is 58 dB down. So you can calculate that. So we're minus 70, and our fundamentals at 11.5, 12. So yeah, it's pretty close. And even if you wanted to confirm it, I do have the FFT on the scope open. Sorry about the glare. And with the cursor function on math, we can see we're about 58 dB below our first harmonic. So RU's accurate enough for me anyway, for the work I'm doing. So it's a little cramped over here. This is actually the El Paso little Joule amp I'm working on. I got the transformers coming this week from Marco in Poland. So I'll make a video about that, but I'm just in the process of mounting things in the chassis, drilling holes. This is a nice big potted out or power transformer from a 50s Rockola jukebox that ran a pair of 6L6s. Anyway, I'll do something on that later, but I'm just measuring these. So it's all ham and iron. I live not far from the factory, Hammond factory, and so I try to support them when I can. They do make nice transformers too. We got a hum balance, AC drive balance, or 6S instead of the drive balance into the output. So David actually over at El Paso Tube Amps makes video on this. He references it quite a few times, adding this into your circuit. Fisher does it, and it does drop the distortion quite a bit. I've measured that. So I basically hook the scope up to the grids of the output tubes on. I keep it on 10x on the scope probe, and overlay. I invert one and then overlay them on the scope here. Actually, I could turn this math function off. We don't need this anymore. Sorry. Overlay them and then just basically make one of the colors disappear under the other one, right? Then you know you're identical. So between the hum balance and this, big help with distortion. I have some test points. So these are 2mm banana jacks, and what I found is they're the perfect size for multimeter probes to push into. So these are just across. I have a point over here that's ground basically, or sorry, the other side of a 1 ohm resistor, and I think that's how I have it set up. I'll have to open this up actually. I don't remember 100%, but I think it's measuring across a resistor, so you can calculate your millivolts externally here to set your cathode current balance, which is right here. So I'll go into that a little more detail. I've had these amps for a couple years now, I think, and they're great. I really enjoy the sound of them. They make about, let's see, let's drive this up to let's go down. We'll go down a little bit here. Let's go to 1% distortion. So 1% distortion, that's 1% distortion. Got about 26 watts at 1% distortion. There's our harmonic profile. It sounds really good. Really good bottom end on this. Lots of good tight bass. The highs are nice too. So overall, it's good sounding amp. So that's that. Let's go back down here. What are we at here? We'll go up to millivolts. I'll show you some square waves. And what we want to do here, or one thing I've figured out that we want to do. So that's our 1 kilohertz square wave. It's obviously you can see nice and square. Tuning the feedback capacitor value and a few other things help that. And one thing I'll do, I won't just strictly use the square form. Sometimes I'll use this pulse measurement, and only because. So hold on a minute. Let me get this pulse set up. Frequency. We want duty cycle 50%. The only reason I say this is amplitude, that's okay. Knock this back to 5 microsecond on our rise and fall time. And that's only because this generator is super quick, and this amplifier doesn't have the bandwidth. You need to at least hit to the 10th harmonic to make a square wave. So I think this is like, 10 nanoseconds or something on the square wave pulse. I don't know. It goes down extremely. It's super fast anyway. It's way too fast for this. So I normally set it to 4 or 5 microseconds. That's more of a realistic test, just because this is a flat out to maybe 50 kilohertz, maybe just below, with the with all the Zobel and everything else I have in here. So anyway, we'll bring us over to the edge. So that's our edge. Zoomed right in, so no overshoot, and basically no ringing. So we'll go back to frequency. 10 kilohertz isn't as good, but oops, let me go frequency 10. It's not bad, but we start to get a little bit of imperfect. But again, there's no ringing, no overshoot. I've tuned that all out. So go back here. Anyway, that's one thing I like to do. I go on, basically set up a square wave pulse that I can control the rising and falling edge time, because it's kind of unrealistic to test at a few nanoseconds, where realistically I think if we did the math, this thing would have to have a megahertz of bandwidth, and it doesn't. So you're never going to get a square wave reproduced that the generator's feeding. So go back to sine wave. Actually, let me go back to that waveform pulse. 20 hertz. We'll look at the 20 hertz square wave. It's not bad either. It's not too rolled off. I think this is what, you'll really see your bass response. The more this is square versus, rolled off this way, from my understanding anyway. Because I've tested some stuff that doesn't perform as well on the bottom end, and it seems like you're almost making a triangle wave. Let's go back to here. Let's go back to kilohertz. So overall, pretty happy. They sound great. It was a fun project. So let's go up. Actually, I wonder what. So starting to get a little bit of flattening off. We're at 30 watts now at 2.8% distortion. And obviously, again, we could get that same number if we did the math. There's 15.2 volts. That's all it's doing. Squaring that, dividing it by the value you give it up here, which is 8. So there's our number there, 15.5. Anyway, I think I explained that anyway before. So that's the harmonic profile. Okay, so let's go 100 millivolts RMS. Shut the input off. You can see our hum and everything. They're very quiet amps. This isn't an accurate scale. But we know our hum. The hum's very low in this amp anyway. It's quiet. If you hook it up to sensitive speakers, you don't hear any hum. So I know those numbers aren't right on the side, but I think that's something to do with the calibration in RU not being set up properly for the decibel scale. And I think that's all I want to show you guys tonight. A little bit of dust on these things. You got to clean them. So I'll maybe pop them open and go over what I did on the inside, another video. And no, I'm very, very happy with them. So I've just finished up a single-ended amp, EL34, 6N1P, driving that. It turned out very good. It's actually my dad's using it right now with his stereo. Is checking it out. He's got a pair of Klipsch Cornwall 3s, so very good match for a single-ended amp just because they make lower power. This makes about 8 watts before the distortion goes up high. I think it makes 2 or 3 watts below 1%, so it's pretty typical for SE amplifier. This one, I think David got 3 watts out of his 807, so it's gonna be more or less the same amplifier. 5U4G. This is a nice old 5U4G. I got some Soviet ones too. I got a logo on the front. Yeah, put a logo on all my stuff. So JT, these are JT 130s, I called them. One channel, 30 watts. Not sure where I come up with that, but 4816 on the back, fused IEC, power switch. I have a ton of these short ball toggles. I really like those. They look nice. I think I got 50 or 60 of them. So yeah, that should be it on this. Just a quick overview of this amp and how it measures. These Williamson amps they're great. They're very good amps if you want to spend the time to tame them and play around with them. It's a good learning experience. I had a really good time. They can make you pull your hair out for a bit depending on the issues, stability wise, trying different things, but in the end it's all worth it.